Everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. Today's video is all about another new topic which is related to your GPAT exam. Basically, the biochemistry division in the GPAT will be covered, and in that biochemistry section we shall be discussing the important aspects of vitamins. So you must understand the basic information about vitamins so that if any question is asked you must be able to solve that question. So firstly, what are vitamins? They are the variety of compounds which have varying complexities which cannot be made by organisms and have to be supplied in small quantities in the diet. Okay, they have to be supplied in small quantities in the diet. A useful working definition is that vitamin is an organic compound which is chemically different from main nutrients. Main nutrients such as fats, carbohydrates, proteins, like that. Okay, so they are required in the main minute quantities in the diet. Vitamins are required in the minute quantities, and if they are absent then they may lead to deficiency and ultimately some diseases. We shall be discussing which disease is caused by the deficiency of which vitamin, so we'll cover that aspect also. So many vitamins, especially those of B group, B1, B2, B3, B5, B6 and B12, the functions of vitamins as coenzymes, but not all vitamins have coenzyme function. So if we talk about their basic types, so they are broadly divided into two main categories. One is water soluble vitamins and other one is fat soluble vitamins. Water soluble vitamins are B complex vitamin, B complex and vitamin C. Okay, these two are the water soluble ones. The fat soluble vitamins are vitamin A, D, E and K. A, D, E, K. Okay, these 1, 2, 3, 4. Four vitamins are water insoluble or fat soluble, and BC, that means vitamin B and C, both are water soluble. If we talk about the deficiencies that they actually cause, deficiencies. So, vitamin B1, which is also called thiamine, lead to the disease called beriberi. Okay, and the vitamin B2, that is called riboflavin, it causes corneal opacity, right? Vitamin B3 cause cheek dermatitis. Vitamin B5 cause pellagra. Okay, pellagra. B6 causes megaloblastic anemia. Anemia. Okay, and vitamin B12 causes pernicious anemia. Okay, pernicious anemia. So these are the different diseases which are caused by the deficiency of vitamin B. Vitamin B belongs to the water soluble vitamin category. B1, B2, B3, B5, B6 and B12. B1 causes beriberi, B2 causes corneal opacity, and B3 causes chick dermatitis, B5 causes pellagra, B6 causes megaloblastic anemia, and B12 causes pernicious anemia. If we talk about the vitamin C deficiency causes scurvy, okay, and vitamin H, which is also called as biotin, so that causes, its deficiency causes dermatitis. Okay, so this is vitamin H which causes dermatitis. If we talk about fat soluble vitamins, that are vitamin A, D, E, and K. So vitamin A causes night blindness. Okay, vitamin D causes rickets and osteomalacia. Vitamin E, which is also called tocopherols, they cause abortion and degeneration of muscles, sterility. Okay, the next one is vitamin K, which we know that they are very important for the clotting of blood, because many clotting factors are actually related to vitamin K. If the vitamin K is deficient, then it may cause clotting deficiency. Okay, so your blood will not get clotted easily. So vitamin K deficiency cause clotting deficiency, vitamin E deficiency cause abortion, vitamin D deficiency cause rickets and osteomalacia, vitamin A deficiency cause night blindness, H deficiency cause dermatitis, vitamin C deficiency cause scurvy, vitamin B12 cause deficiency cause pernicious anemia, vitamin B6 deficiency cause megaloblastic anemia, vitamin B5 deficiency cause pellagra. The deficiency of vitamin B3 causes chick dermatitis, vitamin B2 deficiency cause corneal opacity, vitamin B1 deficiency cause beriberi. Okay, so based on their solubility in water and lipid, we have classified the different types of vitamins, and we have seen how which type of deficiency they cause if they are in deficient condition. Okay, next let's talk about their functions one by one. Let's begin with vitamin A first. So vitamin A is a polyunsaturated alcohol, and it causes free, it occurs in esterified form or free form in milk, in in egg egg, butter, liver, cod liver oil, and shark liver oil. It can also be derived from carotenes that occur as yellow pigment in the plant. The conversion of these to vitamin A involved actually the oxidative cleavage in the center of the chain. There are many carotenes, but only 4 of them give rise to vitamin A. These provitamins occur in carrots, tomatoes, and in grass. Okay, that's why it comes in milk. Okay, young children can carry out this transformation to a limited extent only, and it is almost completely inhibited in the hypothyroidism condition. Okay, so the presence of bile acids of other dietary fat is actually required for efficient intestinal absorption of vitamin A and its precursors and derivatives, which are transported to the liver in chylomicrons. The liver maintain a store of fatty acid esters of retinol, which is sufficient to meet the body's need for several months. The retinol is transported to the tissue bound to retinol binding protein and is reversibly converted into its aldehyde, which is called retinol, or by alcohol dehydrogenase. Okay, so retinol plus NADP positive will lead to the formation of this retinol. In presence of NADP positive will form retinol. Okay, plus NADH plus H positive. So this is actually the reaction which happens. If we talk about its consumption, how it is consumed from diet, we take retinol. This retinol ester will get stored in the liver, and retinol binding, if done in plasma, will lead to the formation of rhodopsin, which is found in retina. That's why it is important for the eyes to function well. Okay, and with an equilibrium reaction, it will be converted into 11 cis retinol. If this retinol, by this conversion by alcohol dehydrogenase enzyme through beta carotene, this all may get converted into all trans retinol also, which may convert it into retinoic acid. Okay, and this will get metabolized. So this is how vitamin A actually works. Okay, so if we talk about the functions of vitamin A, it forms retinal pigment which play an essential role in the normal vision process. It prevents keratinization of epithelium, and it provides nutrition to the epithelium in the mucous membrane as well as in glands. So that is how it is important. As we already discussed about its deficiency of vitamin A or retinol produces night blindness or a condition called xerophthalmia. Okay, and night blindness in the person suffering from night blindness will not be able to see at night or in dim light. This is due to deficiency of the formation of rhodopsin. Okay, rhodopsin formation will be less, so that's why night blindness actually take place. Okay, xerophthalmia, in this the eye become dry, leading to irritation and corneal cirrhosis. Okay, so this is all about vitamin A. If we talk about vitamin D, so although this is a fat soluble vitamin, this has an important, it does the most important form of vitamin D is cholecalciferol. Okay, if we talk about its source, the source of vitamin D is skin. If from sun radiations, our skin forms vitamin D, right? So vitamin D3 is synthesized in the skin from cholesterol derivative, which is ergosterol. Okay, ergosterol, this is a cholesterol derivative. In the presence of UV rays of light from this sun, the UV rays of light, it is also present in the food of animal origin, for example cod liver oil, egg, shark liver oil. The substances are active when these are taken by mouth. Vitamin D3, that is cholecalciferol, a derivative of cholesterol, and D2, that is calciferol, a synthetic derivative of plant sterol. Okay, the immediate precursor of vitamin D3 is 7-dehydrocholesterol. This is the immediate precursor for vitamin D3, which is formed in the skin and sebum and is converted non-enzymatically to D3 by irradiation with UV light. If the skin is sufficiently exposed to direct sunlight, then only enough D3 will be formed to make its intake in the food unnecessary. Okay, D3 is not itself biologically active. The most important derivative is 125 dihydrocholecalciferol. Okay, this form 125 dihydrocholecalciferol is the most active form, which is formed from cholecalciferol with the reaction of two NADPH dependent hydroxylations. Okay, so this 125 dihydrocholecalciferol is formed from cholecalciferol, and this reaction is actually hydroxylation reaction two times. Okay, so the liver will take up the cholecalciferol from the plasma, hydroxylates it, and resecrete 25 dihydroxycholecalciferol, which is taken up and further hydroxylized second time by the kidney. So this 125 dihydroxycholecalciferol, this has a very short half life. Okay, इसका जो half life है, that is, this one is having very short half life. Okay, and the maintenance of effective concentration of 125 cholecalciferol in the plasma will depend on how much this is getting produced from dihydrocholecalciferol. Okay, in irradiated skin, rather than modification of vitamin D, which is absorbed in the gut at regular intervals. So if we prolong exposure is given to the body to ultraviolet light, it does not cause a level of 25 dihydroxycholecalciferol to rise more than the double of the normal value, whereas large oral dose of vitamin D, if we administer, that may rise to tenfold. Okay, so if we are supplying more of these natural things through UV light, then the level may become at the max two times. Okay, but if we orally give vitamin D, then in that case it can become 10 times, right? So that way you can see this 10 times is comparatively better. Okay, if we want to actually increase its level, right? So if we talk about the functions of vitamin D, the most important function is formation of teeth and bones. It increases the absorption of calcium and phosphorus and their deposition in the bones. As I already discussed, the deficiency of vitamin D causes rickets in the children and osteomalacia in adults. The treatment and prevention options are number one, the dietary intake of vitamin D, of course, which will increase it up to 10 levels. And second, and the most natural one, is exposure to the sunlight. So that way we can help from the deficiency of vitamin D. So that way we can have an idea how we can overcome the deficiencies which are being subjected because of vitamin D. Now, if we talk about vitamin E, then it is also called as tocopherol. Vitamin E is also called tocopherol. This is actually present in vitamin E. This is present in vegetable oils. Okay, and it prevents the damage to the membrane lipids. That means it actually maintain the normal membrane structure. Maintenance of normal membrane structure is done by vitamin E. If we talk about its deficiency, the deficiency may lead to abortion and degeneration of the muscles. It can also lead to the deficiency of RBCs, leading to anemic condition. Then vitamin K, if we talk about, it is also present in green leafy vegetables like spinach, radish, coriander leaves. It can be synthesized in our colon by intestinal bacteria. In colon. Okay. Next thing is the function. It helps in the formation of prothrombins. Okay, so this is the most important function because ultimately this is an important factor in coagulation of blood. Okay, if it is deficient in the blood, that means if vitamin K is deficient in the blood, prothrombins will not be produced. That may lead to uh, time or prolonged bleeding. As an example, blood coagulation factor will not be formed. Okay, so the treatment is when it is given either parenterally or oral route will be preferred to prevent hemorrhage. Otherwise, hemorrhage may take place. So you have to give it either orally or parenterally. Once it will be given, prothrombin will be formed, right? So that will help in the coagulation of blood. Next thing is water soluble vitamin like vitamin B1. Okay, this is also known as thiamine. Okay, this is present in fresh food, pulses, liver, nuts, grains, cereals, yeast. Okay, the most important function is it is a coenzyme for carbohydrate metabolism. Okay, so this is the most important function. It also helps in the metabolism and synthesis of pentose synthesis. Okay, so these are the functions of vitamin B1, but its deficiency, if thiamine is uh, deficient, then it may lead to the disease called beriberi. Okay, its deficiency, which is characterized by anorexia, that means loss of food intake, you'll not get hungry, weakness, then bradycardia, with death usually caused by heart failure. So that is the major drawback with vitamin B1. Okay, if we talk about vitamin B2, it is also known as riboflavin. Okay, it is present in yeast, liver, curd, pulses, milk, and green leafy vegetables. The function is to keep the skin healthy and normal. So this is very important for your skin to function well, to look well. It forms two derivatives which are coenzyme for dehydrogenase. These are FMN and FAD. Okay, uh, these two derivatives are the coenzyme for dehydrogenase. Okay, next we talk about the next vitamin, that is vitamin B3, which is known as the other name of it is nicotinic acid. Okay, nicotinic acid. If that is actually found in yeast, liver, and cereal grains, it is actually synthesized in the body from amino acid, main source tryptophan. Tryptophan. B3 is synthesized from tryptophan. Okay, this is B. Tryptophan. And the function is this it forms two coenzymes which are very important. They are usually you found in biochemistry in almost every reaction, NAD positive and NADPH positive. Okay, so for number of dehydrogenase reactions, it will be very important. Vitamin D B3. Okay, NAD positive, NADPH. And for vitamin B2, it forms two derivatives, FMN and FAD. They are the two coenzymes of dehydrogenase. Okay, so FMN and FAD, if we talk about, so FMN is flavin mononucleotide, and FAD is also uh, flavin adenine dinucleotide. Okay, mono and dinucleotides. Okay, flavin adenine dinucleotide. So these are also coenzymes which are redox active. Okay, so they are fmn and fad, right? So they are actually derived from riboflavin, that is vitamin b2, and d3, because this is nicotinic acid. So as name depict, it can form nad and nadh positive. This is nicotinic acid. Okay, so that's why it is related and will form nad positive and nadp positive for a number of dehydrogenases. So what about its deficiency? The deficiency of vitamin b3 will cause pellagra, the disease called pellagra. Okay, if we talk about the next vitamin, that is vitamin b6, this is known as pyridoxine. Okay, pyridoxine. This is called pyridoxine. It is present in yeast, cereals, and eggs. The main function of vitamin B6 is to form coenzyme which actually participate in amino acid metabolism. And if we talk about its deficiency, then deficiency causes convulsions and anemia. The deficiency of vitamin B6 causes convulsions and anemia. And okay, vitamin B5, this is also known as pantothenic acid. Pantothenic acid, this compound has not been shown to cure any specific deficiency disease in man. Okay, and if we talk about vitamin H, this is known as biotin. It does not cure any specific disease in man. Okay, so it is not used for the treatment of any disease. Another important compound is folic acid. Okay, folic acid. So folic acid is pteroglutamic acid. It is obtained from green leafy vegetables, yeast, and liver. It helps in DNA synthesis. Okay, this helps in DNA synthesis and formation and maturation of erythrocytes. If we talk about erythrocytes, so its formation and maturation of uh, erythrocytes, this folic acid is actually involved. The deficiency of folic acid cause megaloblastic anemia and GI diseases. Next one is vitamin B12. This was B6, right? Folic acid. Next is B12. It is also known as cyanocobalamin. It is present in animal products like meat, like liver, fish. That is why most of the vegetarians are deficient in vitamin B12. Okay, it is also synthesized in human colon. Its deficiency occur due to defect in GI absorption or lack of intrinsic factor, and not due to deficient diet. Okay, so it promotes DNA synthesis. What is its function? It promotes DNA synthesis, like your previous one, that is vitamin B6. It promotes DNA synthesis. It helps in maturation of the erythrocytes. Whatever erythrocytes your RBCs are being formed, they will be matured with the help of vitamin both B6 and B12. They are required for the formation of myelin also, right? Deficiency diseases. This occurs due to the defect in GI absorption and can lead to pernicious anemia and degeneration of your spinal cord. Okay, so the deficiency of vitamin B12 can cause degeneration of your spinal cord. Okay, so it's quite serious, especially for non vegetarian diet people. So the treatment include diet improvement, that means you have to take more animal products, availability of intrinsic factor, and drug therapy. Obviously, you have to take parenterally vitamin B12 on emergency basis if you are suffering from such disease. Next vitamin is vitamin C, the another water soluble vitamin. It is also known as ascorbic acid. The source is it is present in sour fruits like, or you can say citrus fruits like amla, orange, lemon. It is also present in green leafy vegetables. The function of vitamin C is the it help in the formation of collagen, which is important intracellular material of the connective tissue. Okay, C for collagen. Okay, so that way you can learn this. Okay, it helps in the wound healing process because of anti-inflammatory activity also. Okay, so if you are intaking vitamin C properly, so your wound will get healed faster, uh, at a faster rate. If I talk about its deficiency diseases, vitamin C deficiency leads to a disease which is called as scurvy. Scurvy means the swelling of your gums. Okay, the important factor which is associated with these water soluble vitamins, especially vitamin C, are they cannot be stored in the body. Okay, storage is a big challenge because most of the body part is water. So whatever vitamin you are intaking from outside also, then that would get excreted fast, so body will not be able to store it like vitamin A, D, E, K, because they are fat soluble vitamins. Your body is able to make them stored inside the body, but for these vitamins it is quite difficult for the body to store them, right? So this was all about the vitamins, the major aspect. The only thing that you have to majorly focus upon is the deficiency diseases and the coenzymes which are actually involved, like with thiamine pyrophosphatase, pyrophosphate, for riboflavin, flavin mononucleotide, and flavin adenine dinucleotide, as we have discussed. For pyridoxine, pyridoxyl phosphate is a type of coenzyme. For nicotinamide, diphosphopiridine nucleotide and triphosphopiridine nucleotide. For pantothenic acid, coenzyme A. For biotin, biotin is the name of the coenzyme. Folic acid, tetrahydrofolic acid. Cyanocobalamin, cobamide coenzyme. Okay, and these coenzymes are helpful in various types of reactions like thiamine pyrophosphate, which is actually the coenzyme of vitamin thiamine. It is involved in the decarboxylation of alpha keto acids. Then your FAD and FMN, right? Flavin mononucleotide and flavin adenine dinucleotide, which are actually obtained from riboflavin, are involved in the redox reactions, that is oxidation reduction reactions. If we talk about pyridoxine related coenzyme, pyridoxyl phosphate, this is involved in the decarboxylation, transamination of the amino acids. If we talk about nicotinamide, which is involved in the coenzyme diphosphopiridine nucleotide and triphosphopiridine nucleotide, this is also involved in the oxidation reduction reactions. Here we discussed NAD positive and NADH positive, right? Pantothenic acid is involved in the coenzyme A, which is actually involved in the transference of acetyl group. If we talk about biotin, it is actually helpful in the carbon dioxide fixation reactions. If we talk about folic acid, this is related to tetrahydrofolate or tetrahydrofolic acid, which is involved in various reactions which involve actually single chain carbon compounds. Cyanocobalamin is cobamide type of coenzyme which is actually involved in carbon-carbon chain isomerization. So that way cyanocobalamin or vitamin B12 is involved for carbon chain isomerization. So this was all about vitamins, how and they are important, what their deficiency causes, which type of disease, and what are the different coenzymes which are associated with these vitamins, and the type of reactions which are actually associated with these coenzymes, right? I think you enjoyed this video. Do click on the like button if you like this video, subscribe this channel, share it on social media as well as your friends who are actually the seekers and of GPAT related material and the videos. Thank you. Have a nice day.